The binomial distribution tells us the theoretical probabilities under the assumption that we have a fair coin. So if we have a fair coin, we're noticing that a lot of the probabilities fall between, again, looks like about 5 and 11 is where the greatest likelihood of seeing the number of heads fall between. Now anything outside of that, seeing one head or seeing 15 or 16 heads is very, very unlikely. But at least right now, if we look at the probability of seeing what we saw, well, what do we see? We saw 15 heads pop up, and the probability of getting something that extreme or more extreme, in other words, what's the probability or I guess I should say, how improbable is it to observe something as big or bigger than what we saw? Well, if I add these two together, if I do equals this plus this, I notice that that probability is really, really, really small. There's about, in terms of a percentage, there's about a 0% chance rounded to about 0.03% chance of getting 15 heads and 16 tosses. Well, is that guaranteed proof that the coin is unfair? No, it's not guaranteed proof, but it's beyond a reasonable doubt. So we have evidence beyond a reasonable doubt. So that's in quotes. Well, what is reasonable doubt? For us in the statistical world, objective evidence is if the likelihood of our observation is less than 1% likely, or less than 5% likely, or less than 10% likely, that's typically when we'll reject. So which one is it? Well, it depends on the context. If you're a biologist and you're studying new medication, then you want your reasonable doubt to be very, very high, meaning that you want to reject only if you experience some extreme stuff. But now this is set in advance of the study. So you can't go back and say, well, we chose alpha equals, we chose 1%, when in fact you only chose it based on your observation. You got to choose that ahead of time. Otherwise, you're basically lying with statistics. You're altering probabilities and you're altering observations. So if this wasn't a big deal and you're like, well, you know what, 5% is good enough for us, then anything less than 5%, like 0.03%, we would conclude that the coin is probably unfair. Because that's beyond, getting 12 or 13 is one thing, but getting 15 or more heads is way, way tinier than a 1% chance. So that's beyond a reasonable doubt. And therefore we would conclude that this coin, the proportion of the time that we get heads is greater than 50%. Okay, well think about golf balls here. So a golf ball, we know that typically the null hypothesized value is 2.4%. So we have 2.4% error rate. Now we have speculation. We want to, as a head of logistics, determine whether it's any different than 2.4%. If it's too low, then maybe since we expect 2.4% error rate, we're convinced that we're sending out defective golf balls. But if it's greater than 2.4%, then we also have a problem. We're basically wasting a lot and we're throwing a lot away. So we want to basically test, well, is it any different? And the fact that we put not equals here could go either way. It could be smaller than or it could be bigger than. Well, if your stringency is 1%, that's your beyond a reasonable doubt. If what you've observed is less than 1% likely, and it can go either one way or the other, well, let's think about a probability distribution. So we would have to create one. We don't know exactly what that would look like. Probably pretty similar to what we're seeing, of the number of golf balls in the sample that can possibly be defective. And we've got to say, all right, well, if we've got 1% is beyond a reasonable doubt, and it could either be greater than or it could be less than, then we probably want to split that probability up. So we're going to have 0.5% over here and 0.5% over here. We don't want 1% in either tail, because then we've compromised the integrity of our study. It's no longer a 1% stringency, it's a 2% stringency. So we would reject if the likelihood of what we saw is either greater than this amount right here. I'll call this x sub 0, and I'll call this x sub 1. So if you observe a sample that's beyond 2.4%, then you would reject if it's bigger than this value, and if your sample is smaller than that, you would reject if it's smaller than this particular value.